So we are going to prove that the integral of what? Log x base a, the x, is equals to what? Where a is greater than what? 0. Is equals to what? 1 all over what? ln of what? A. X ln of x minus x plus our arbitrary constant. So we are going to prove it. Now we are having log what? X is what? A. Do you still remember change of base? So using change of base formula, we are going to have that this thing is what? Log what? X is what? We are introducing a new base of our choice. Base what? E. You know in normal logarithm, we used to introduce base 10 for easy solving, okay? But in this one, we decided to introduce what? Base E. All over log what? A to the base what? E. If you still remember your change of base, go back to your book. Good. Now, I told you something that anytime you see logarithm of a number to the base of E, that thing is something as saying ln of what? This number. Okay? You still remember it? Anytime you see any logarithm to the base of E, it means ln of that logarithm. Are you there? So, this one will be over what? Go, ln of A. So any logarithm where the base is E, it means ln of that logarithm. Do you understand this now? So let's continue. If it is what? For example, you have a number and the base is what? So we solved it now. I think we solved it where we have that question we solved. Yes, where we treated it. So let me put it like this so that we have ln of what? Okay, sorry. Log x base E, right? Over log A base what? E. Is equals to ln of what? X over ln of A. Sorry, ln of A. True of us? So we having what? Now, since we have this now, we have transformed this to, okay? So we can now take the integral. So we have the integral of what? Instead of writing this now, we are going to put this, right? We are having integral of ln of x over ln of A. Are you there? Now, this function we want to integrate now is called what? The integral. Say it.
Integral.
Now, this one is called with respect to. This one is called the integral, which is denoted as elongated what? S. It's called what? The integral. So this thing is called what? The integral. For example, if you have integral of 2x dx, this thing is called what? The integral. The function you want to do what? Integrate. Are you there? So let's continue. We'll be having integral of ln of x over what? ln of A, with respect to what? X. Now if you look closely, we are having ln of x and we are differentiating, we are integrating with respect to what? X. Are you there? But here we are having ln of A, we are integrating with respect to what? X. So we are going to treat this one as constant because this one is having x, this one is having x. True of course, it can integrate. But this one is having A, this one is having what? X. So we are going to treat this one as what? Constant. Because it is not among what we cannot differentiate it because we are not, if we are having with respect to A here, we are going to treat this one as what? Constant. But we are having with respect to X. So we are going to tell this one, please come outside. We are having family meeting. True of us? You tell this one, please brother, come outside. We are having family meeting. So it's now obeying you. Or be outside. If you multiply this, you are still going to get this. True of us? 1 times this will give you what? ln of x over what? This. Because this times this will give you what? So that we get back this thing. This time this will give you what? ln of x over, this one is over 1. This time this will give you ln of a. Do you get it now? So, what are we going to do? Now we are having ln of what? X. Do you know the integral of ln of x? Is here now? Or do you want to know how we found it using this thing? Okay. No. Integral of ln of x. This one is derivative of ln of x. Is what? 1 over x. Right? Now, integral of ln of x. Let's find it. Let's find it using this thing. Integration formula. Now, using in integration, we have integration by U substitution, integration by trigonometric substitution, integration by parts. So we are going to use integration by parts here because of what? We are having products. I'll still teach you guys integration so that you understand it more better. We are having what? Products here. So we are going to apply integration by what? Part formula. So using integration by part formula. Yes, parts. So integration by part formula is just trying to tell us that integral of u dv is equal to uv minus integral of a du. That is the word formula. Are you there? Formula for integration by what? Parts. Now, they have proof for this formula, but just know the formula. Just know the formula. So, there's another thing we call layat. Say layat.
Layat.
Using layat also. Layat is what? L is for logarithm. I is for inverse series. A is for algebra. C is for trigonometry. And E is for what? Exponent. Now, you'll be wondering what this layat is doing here. This layat is very important in integration by what? Part. Are you there? So it's very, very what? Important. Why is it important? It tells you the one you make your or your what? V. Now, under this integration by parts, we are looking for. Okay, let me bring this thing we want to integrate. ln of x, the word x. Now we are looking for our yo. We are looking for our du. We are looking for our v. And we are looking for our what? dv. These are the 4 things we are looking for. Now, this layat tells you the one you are going to make for you. Let's go. Is there any logarithm here? We are having logarithm. Therefore, our yo will be what? ln of what? X. Are you there? So, there are some functions that you still have logarithm and what? Trigonometry. For example, they will ask you to integrate ln of x cos what? X, the x. Something like this. Then, if you are having logarithm first, you make what? ln of x your yo. And make your dv what? This what? Cos x. Are you there? Yeah. So, there are some functions that come in that manner. So, let me clean this place. Don't worry, we'll still find it. Don't worry. So our du will be what? Let's differentiate this. Let me differentiate it so that you see. If u is equal to ln of x, du over the x of ln of x will be what? Let me know whether you remember. Alright. Thank you. 1 over what? X. We have it there, right? Is what? 1 over x. Is equal to 1 over x, right? What are we looking for? Our du. We cross multiply, right? So we are going to have x du is equal to 1 dx, right? We divide both sides by x. We divide both sides by x. our DO, our DO will give us what? 1 all over x what? The x, okay? This one? See? This x divide this one. No, no, it will not divide it. This one is the x with respect to those who cannot divide it. So, do you see how we got our DO? Any question? Okay. Now, let's proceed. Our DO is now what? 1 over x what? Yes, okay? Good. Now, let's look for our v. To look for our v is what? Integral of what? The v. So let's ignore our v first and look for what? Our dv. Yes. So what will be our dv? You know that we can just say that there is 1 here. We can just attach 1 here. Because 1 times this thing is the same thing with this thing, okay? So we can just attach 1 there. And we now say that our dv is equal to what? 1 the x. Are you there? So we have attached what? 1 here. So our dv is what? 1 here, x. Now our v will now be what? Integral of this dv, which is integral of what? 1 the x. Are you there? So let's integrate this integral of 1 the x. Now we have integration formula. Integral of x to the power of n with respect to x is equal to what? X m plus 1 over m plus 1 plus what? The arbitrary constant. This is power root of what? Integration. Now applying it here, we are going to get what? Our v is equal to, let me not just waste your time. Integral of 1 with respect to x is what? X. You know that differentiation is the reverse of what? Integration. Are you there? Derivative of x is what? Derivative of x is what? 1. Derivative of x is what?
1.
Of x is what? 1. Now, integration is the reverse of what? Differentiation. So, integrating this one with respect to x will now give you backwards your what? X. So, integration being as to what? Differentiation. Do you get it now? So, integral of what? Integral of 1 is what? X. Are you there? Now it's supposed to be x plus c, but let's leave the c now after we are going to what? Put it. Now let's put it inside this our formula first. We have integral of u dv is equals to uv minus what? V du, right? So this thing is equal to what is our u? ln of x, right? Our u is ln of x times our v is what? Please remember this v is x. Our dv is 1. Yes, okay? Our v is x, right? Minus integral of our v is what? Still x, right? Our du is what? 1 over x what? Dx, right? Now we are going to have that integral of u dv is equal to ln of x times x is what? X ln of what? X. Are you there? This times this is just x ln of x. Are you there? So minus this thing we cancel this 2 of us. We are having integral of 1 the what?
X.
X. 2 of us. So we are going to have integral of u dv is equal to x ln of x minus integral of 1 is what? Let me know where that. Thank you. X. So integral of 1 with respect to x is what? X plus our arbitrary constant, because we are dealing with indefinite what? Integral. Dx. This thing is with respect to, we are integrating something with respect to another thing. That means if it is definite integral, it's just trying to tell you that if you have area under a curve, for example, you have from A to B, He's just trying to tell you that this area under you come will now be integral from what? A to what? Okay, we have not finished yet, sorry. We have gotten this thing, right? Right? Therefore, integral of ln of x, the x is what? X ln of x minus x plus c. True of us? True of us? Now, where is our main question? We are asked to see where we stop, right? We have 1 all over ln of a. We told this one to give us space, true of us. And now, we are going to accommodate it now. 1 all over ln of a. Have we integrated this? What do we get? Then times x ln of x minus x plus our arbitrary constant. This is the derivative I gave you here. Yes. Do you see it now? So the derivative of x log x base a, the x is what? 1 over ln of a, x ln of x minus what? X plus our arbitrary constant. More video. Jesus, 16 minutes. Oh, more. Yeah.